I'm Paul Rako, and this is the Atmel Edge, the show that makes you well-rounded and well-grounded. The show's for engineers, technicians, hobbyists, makers, anyone who wants to learn about system-level electronic design, embedded systems, and even mechanical engineers might enjoy it. Today we're lucky in that Henrick Flodell is with us. Your title, Henrick?
I'm the Tools Marketing Manager at Atmel.
But the other big part of your job is the Studio 6 development environment. And I've heard it called IDE, Integrated Development Environment, and IDP, Integrated Development Platform. Do you have a preference, what we call it?
So what we call the IDP, the Integrated Development Platform, is actually more than Studio. We call what we refer to as the IDP is, it's Studio, it's the explained evaluation boards, it's the Atmel software framework, it's the Atmel gallery, it's sort of the whole ecosystem of Atmel tools that comes together with sort of Studio as the hub in the center of it. So, you use Studio, you're in Studio, you're working on your project, and from there you can access all these other parts of the ecosystem, and that sort of makes it the integrated development platform.
Okay, that's a great distinction, including Atmel Spaces, I guess, where you can share and collaborate.
Exactly, so you have the collaboration environment there, you have all your example programs for the boards that you're working on, or if you have your own board, you might have based your application off something that you got from ASF initially.
Oh, great. And now the Studio just came up with an upgrade 6.2, isn't it?
Yes, we launched a beta of the 6.2 version of Atmel Studio in the end of February at the Embedded World Show in Nuremberg. And
they can download it now. If I go to Atmel's website, I can get this 6.2 version.
Yes, absolutely.
And there's some, you talked about AVR1 having trace capability, which is helpful to debug where your program's been. There's program trace and data trace in Studio 6.2, is that?
So what we're doing in Studio 6.2, we focused that release on adding some advanced debug functionality that we didn't used to have in Atmel Studio. Some things are like, if you go a couple of generations back with Atmel tools, like the AVR Studio 4, we had data breakpoint capabilities there. We lost it when we moved over to 5, but now we put it back again in 6.2, so we have data breakpoint support for all of our microcontrollers again, which is great because it's really useful. We've also added support for data trace. And this is, data trace capability is one of these things that kind of, it varies depending on the micro you're using, whether or not it actually supports us collecting it or not. But if you're using Atmel ICE and you're working with, say, something based on a SAM3 or a Cortex-M3 or a Cortex-M4 core, you can access this data trace information because it's built into the core of the microcontroller in a non-intrusive way. On some of the other cores, we've had to do some sort of tweaks to be able to access the data in a not super intrusive way, but you have to, it's a little bit more intrusive than the capabilities that you can get on some of the more advanced micros. But this is basically a set of features that we haven't had in Studio before that is going to make it a lot easier for developers to be able to quickly spot the issues that they're having with their applications.
We were talking, you mentioned data breakpoint. Is that something where you can look at an established data in a register or something and break on that? So basically what a data breakpoint is, if you sort of compare it to a normal one, a code breakpoint you set on an instruction, and when execution gets to that address, in the code, it stops. Data breakpoints you can set on memory locations or registers, and you can halt execution on reads or writes to those addresses. And you can also use these, it's a similar system in some of these cores for you to set what's sort of called watch points and trace points. So you get to an address, say that you have a variable at a location, you can start watching this variable, and you can see how it's updating in real time during the execution of the application. And we've been collaborating with a company called Percepio to do some really nice sort of views in Atmel Studio to be able to render this data. So you can basically, you set up for a number of variables that you want to watch them over time, let your application run, and it will graph it in Studio. Oh, wow, and you can do things like you can trace interrupt activity as well with this, so you can see which interrupt triggers, how often, figure out if everything is running according to how you planned it when you designed the application. That's right. When you get into interrupts and interrupt-driven programs, it's a whole level. I mean, Arduinos are great, and we love them here at Atmel. But as soon as interrupts and event-driven kinds of concepts come in, this advanced debugging is just a great thing to have. And I heard you mention two things that just snapped me was, you've got a Stack Overflow You can have the tool help you find that, and you've got or if you've got some memory corruption where something's in a memory location you don't understand, you can use the tool to help you go figure that out.
Yeah, there's all kinds of things that you can do with this trace data. We're actually in the beta that we have out now of 6.2. There are some features that are going to be in the final release that they weren't really done in time for the beta, so they haven't made it in yet. But one of them is what we call statistical profiling, and this is based on sampling the program counter at certain intervals during the execution of the application. So you can basically build like a little graph of this is the areas of my application that actually got executed, and it's really good for trying to figure out are there any dead code in my application? Do I hit all of these execution paths the ways that I thought that I would? Where does my application spend the majority of its execution time? Because those are the areas that I need to focus on, optimizing well, making sure that I, reduce power consumption in those areas. Maybe I realize that I'm spending an absurd amount of time in a function, where I might as well be putting the micro to sleep, save power that way.
Is there still problems like recursive things where you might get trapped, and this would kind of help you figure out if you had that kind of problem?
It will definitely help you find that, because you'll immediately see that, okay, I'm not progressing past this point in the execution of my application, something must be wrong.
Big spike. Well, this is great. You've done so much with the hardware part, with the Atmel Ice. Now Studio 6 was always great. Now we have 6.2. You can do ARM, you can do our 32-bit AVR and our 8-bit AVR all in one platform. Anything else comes to mind that you'd like people to know about Studio 6.2?
Yeah, so there's one other sort of major feature that we're introducing in 6.2 that is going to be available in the final release, and this is we're going to add RTOS awareness to
real-time operating system.
Yes. So basically, if you run an RTOS kernel and you have, if you have an RTOS and you're sort of basing parts of your application on that, the RTOS is going to consume certain resources in the microcontroller. It's going to need a bit of memory for its stack. It's going to need probably some memory for semaphores and things to allow you to synchronize your threads and things like that. These resources are, they're not really part of your application. They're part of the RTOS. And the RTOS awareness basically makes it possible for the debugger to separate these resources from the ones that you're using, the ones that you have to deal with on your side. And it also lets you watch these, the queues and everything that has to do with the RTOS in a way that makes sense based on, what kind of a resource it is that you're looking at.
I think that was always great about Atmel, that the AVR was designed with C programming and code efficiency in mind. And now seeing you move up the chain to worry about the operating system and help our customers get through that is something to be really proud of. And I'm really glad Atmel sees this assistance to the customer base.
Yeah, I mean, we try, with the integrated platform concept that we have, we try very hard on making sure that, these tools enable developers to get to market quicker with, what they're working on. We want them to be able to focus on, the sort of the tricky parts in the application development and not have to worry about, finding the right tools and putting everything together. We make sure that everything is sort of available from within the platform.
Oh, that's
also,
great.
I mean, I just want to add to that, besides the platform, we also work with, for instance, on the ARM side, with the ARM connected community and all the other players in it, and make sure that, from our platform, you can go out and you can add, the support that is available from this larger ecosystem for you as a developer during that phase as well.
So embedded programming has moved beyond my day when it was assembly language in little 8-bitters, and Atmel's keeping up. We're going to wrap up now. This is the Atmel Edge. I'm Paul Rako. This is Henrick Flodell. Thank you so much, and tune in next time.
All right. Thank you. Thanks, Paul.